We're going to do 1 through 10 on this Trig Proofs worksheet for the first night of homework. So remember, you need to practice memorizing your identities. These obviously are a lot easier if you have them memorized, but also we won't get any sort of formula sheet for the AP Pre-Calc exam, so you need to be able to do these without. Okay, we want to show that that tangent theta is equal to sine times secant theta. So usually I say work on the more complicated side. So I'm going to work on this side. And I'm going to begin by rewriting secant as 1 divided by cosine theta. That's using a reciprocal identity. And I'm just multiplying those two things together. So that can become sine theta over cosine theta. And we have a quotient identity that says sine over cosine is equal to tangent theta. So remember, you're working on one side only until it matches the left side exactly. So you cannot work on both sides and have them meet in the middle. You can work on this side a little bit to see where you need to get to here, but you can't stop at sine over cosine on both sides. Okay, next one, I would consider the right side to be more complicated. There's more to do there. Anytime I see a single term, well, there are a few ways you can go with this. You can see a single term and divide this out, or if you see an identity right away, cosine squared plus sine squared is equal to 1. That's our Pythagorean identity, divided by cosine squared theta. We have a reciprocal identity that says 1 over cosine is secant, so it's also true that 1 over cosine squared is secant squared theta. So that's our second proof. For the third one, I'm going to start on the left side this time because this has more to do. I don't see any identities right off the bat because we've got some multiplication here. So let's rewrite things in terms of sines and cosines. So cosecant squared is 1 over sine squared theta. Make sure you're writing thetas for all of these. You don't get credit if it's just 1 over sine squared with no angle there. Tangent squared is sine squared theta over cosine squared theta. And there's a minus 1 over here. So we're able to cancel this sine squared divided by sine squared. That divides to 1. So now I'm left with 1 divided by cosine squared theta minus 1. I'm trying to get to tangent squared. So think back to your identities. We do have a Pythagorean identity that says tangent squared theta plus 1 equals secant squared theta. And if I look at what I have here, I have secant squared theta minus 1. So remember, we often should be looking for rearranged versions of our Pythagorean identities. So again, the better you know them, the easier this will be. So if I were to solve this original Pythagorean identity for tangent squared, I would get secant squared minus 1. So secant squared minus 1 is tangent squared theta, and we're finished because we got this to match the right side. All right, I'm going to start on the left side here. I think a fraction is a little more complicated than what we have here. So to begin, I always check for identities. I see a 1 minus cosine squared, which is sine squared. That's a rearranged Pythagorean identity as well. And the longer we do these, the more often you'll see this pop up. So we have in our notes that sine squared plus cosine squared equals 1. So again, if you solve this for sine squared, if you move cosine squared to this side, you get 1 minus cosine squared. So tangent theta over sine squared theta. Now I want to split this up because I'm trying to simplify it to this, and I'm thinking ahead. This is 1 over cosine times 1 over sine, so I'm trying to kind of get there. I'm going to rewrite tangent as sine theta over cosine theta using my quotient identity. And then instead of dividing by sine squared, I'm just going to show that that's times 1 over sine squared, just to separate this out a little bit. And then I can more clearly see what cancels. This sign on top cancels with one of the signs in the sine squared. So I'm left with 1 over cosine theta times sine theta, if I multiply that into one fraction. And always look back to what you're trying to get to. 1 over cosine theta is secant theta, and 1 over sine theta is cosecant theta. And I've matched the right side exactly, so that's finished with that one. All right, for number, I want to get these to match color. For number 5, For number 5, definitely the more complicated side is on the left. Anytime I see a mixture of trig functions and no clear identities, I just start rewriting in terms of sine and cosine right away. So secant divided by cosine. So secant is 1 over cosine theta. And then again, instead of saying divided by cosine, let's just say times 1 over cosine. So it's kind of like saying, pulling this out and saying this is 1 over cosine times secant, and then I changed the secant. Same thing here, minus tangent is sine theta over cosine theta. Now, instead of divided by cotangent, which is cosine over sine, instead of dividing by that, I'm going to multiply by the reciprocal, multiply by sine theta over cosine theta. So what does this get me? This gets me 1 over cosine squared theta, because nothing cancels, minus sine squared theta over cosine squared theta. All right, now I know I put everything in terms of sine and cosine. Usually that allows me to cancel something, but in this case it doesn't. I'm trying to show that this equals 1, which means I'm probably going to use a Pythagorean identity. So let's look at 1 over cosine squared. Maybe I change that back to secant squared theta. Sine over cosine squared, sine squared over cosine squared is minus tangent squared theta. And let's scroll back up here to our Pythagorean identity again. The original one we have on our sheet is, in our notes, is tangent squared plus 1 equals secant squared. If you subtract tangent squared to this side, you're going to be left with 1. So secant squared minus tangent squared is equal to 1. Pythagorean identities, like I said, often get rearranged. So you've got to just keep practicing that. And the more you see it, the more you'll recognize it. We can only do so many versions of these. They all kind of use similar tricks. Okay, number 6. I don't see any identities right off the bat. But if I see something to a high power, that's usually a hint to factor it. So let's start on the left side. If this were x to the 4th minus y to the 4th, hopefully you would start with a difference of squares. So it's the same thing here. If I factor this as a difference of squares, I get cosecant squared theta plus cotangent squared theta times cosecant squared theta minus cotangent squared theta. Now, one of these is an identity, so the question is which one? So again, Pythagorean identities. Remember, we know tangent squared plus 1 is secant squared. Remember, the trick for remembering was cotangent squared plus 1 is then cosecant squared. So same rule as tangent squared, you just put some cos in front. Okay, so if that's the case, how can I rearrange this? Now, I can subtract cotangent squared to the other side. So cosecant squared minus cotangent squared, this second set of parentheses that I wrote, this is just 1. Another hint to trade out this one is that you're trying to get this, which is what I have in the parentheses here. Because these are proofs, I'm showing, as many steps as I can without going overboard here. So like your proof should be more than one step. So that's why I'm showing the times 1. And then therefore that is cosecant squared theta plus cotangent squared theta, which matches the right side of the equation. So we're finished. On to number 7. So how do I know which side is more complicated? There's not necessarily a right or a wrong side to start on. If I see something squared, I kind of think to start foiling it or distributing it. So I think I'm going to start on the left side. But maybe I could start on the right side and switch to sines and cosines, or trade out a Pythagorean identity or something. But I'm just going to go here. If I square this binomial, I get 1 minus 2 tangent theta excuse me, plus tangent theta squared. So that's a good sign because I can see parts of this are starting to match. So I have the minus 2 tangent. What about this secant squared here? Well, remember, 1 plus tangent squared is secant squared. That's a Pythagorean identity. So I'm just going to go ahead and say secant squared theta minus 2 tangent theta and call that one a day. This is as short as a proof would get, just 2 lines here like this. All right, next one. I always consider the side where I'm adding fractions to be the more complicated side. There's more for me to do on that side, so I'm going to start here. And I like to start with changing to sines and cosines again, just to see if anything cancels to begin with. So cotangent is cosine theta over sine theta. I remember that quotient identity because the c for cotangent has the cosine or the c on top. Now, if you're dividing by cosine, that's the same as multiplying by 1 over cosine. So I'm going to separate this out. Instead of over cosine, I'm going to say times 1 over cosine. So that's the first term. And then plus secant is 1 over cosine theta. Instead of dividing by cotangent, which is cosine over sine, I'm going to multiply by sine over cosine. Another way to think of that is instead of dividing by cotangent, we can be multiplying by tangent since they're reciprocals of each other. So we do get some terms to cancel. Cosine over cosine divides to 1. Nothing cancels over here, so here's what I have now. 1 over sine theta plus sine theta over cosine squared theta. Now that I've simplified these fractions as much as I can, I want to add them together. So the common denominator would be sine theta times cosine squared theta. This fraction, first fraction, had to get multiplied by cosine squared over cosine squared. So cosine squared times 1 is cosine squared theta. And then this fraction had the cosine squared but not the sine, so it needed to get multiplied by sine theta over sine theta. So that's going to be plus sine times sine, so plus sine squared theta. And then this should start jumping out at you. Cosine squared plus sine squared is 1 over sine theta cosine squared theta. Always check back to what you're trying to get to. We're trying to get secant squared times cosecant, so we have that. 1 over sine is cosecant. 1 over cosine squared is secant squared. I want the order to match so I don't have to write an extra line. So it's okay to use the commutative property in your head to flip this around and say secant squared theta times cosecant theta. All right, number 9. Now these two sides are almost the same. It's just about where one's sine squared, one's cosine squared, so it does not matter which side you start on. I'm going to say I start on the sine squared side. If I have 2 sine squared minus 1 over here, that doesn't factor nicely because of the 2. But on the right side, I only have cosine squared. So how can I change a sine squared to a cosine squared? I can again use my rearranged Pythagorean identity. If sine squared plus cosine squared equals 1, then if you get sine squared by itself, you get 1 minus cosine squared. This is our first round of this homework, so the substitutions might not be obvious, but as we do more of this work, it'll get more familiar. So I traded out sine squared with 1 minus cosine squared. Next thing to do would be distribute the 2 through. So that's 2 minus 2 cosine squared theta. This minus 1 is still here. 2 minus 1 is 1 minus 2 cosine squared theta, and that's what we're trying to get. Okay, last one for tonight's homework. I definitely say the left side is the most complicated. Let's change to sines and cosines to see what we're working with. So secant is 1 over cosine theta. Tangent is sine over cosine. Times sine is just so like times sine over 1 if you want to show yourself that. So these two fractions already have a common denominator. It's cosine theta. So all we have to do is put the numerators together. 1 minus, this is sine squared theta. Now we just made the opposite substitution in problem 9. 1 minus cosine squared is sine squared. So if you see 1 minus sine squared, that's cosine squared theta divided by cosine theta. And cosine squared over cosine reduces to cosine theta, which is what we're trying to get. So these might feel a little unfamiliar at first. It can be hard to know where to go, where to start. So we've got some advice about that in our notes. And a lot of this just kind of takes practice. Like I said, you'll see a lot of the same ideas and a lot of the same methods and tricks as we do more of these.